rules for each piece. Today, we are talking about what is called the greatest integer function. And I don't believe you have seen this one before. It's sometimes called the step function. So the notation, it has these double brackets on the side. And it gives you integer values only. So if you put in an integer, you get out an integer. What is an integer? What kind of number? Not fraction. It's positive and negative whole numbers. So like -2, -1, 0, 1, 2. So no fractions or decimals. So if you give an integer value, that's what you get out. If I say greatest integer of -3, -3 is an integer, so that's what it gives me. But for anything else, it will give you an integer value that is the biggest integer less than that number. For instance, if I said 6.3, 6.3 falls between which two integers? 6 and 7. You give me the smaller one every time. So it would be 6. The greatest integer of 6.3 is just 6. If I said the greatest integer of 2.9, it falls between 2 and 3, so you always give me the smaller one. So you give me 2. So you can't get out anything bigger than what you put in, and you only get integer values. So if I ask you to find the greatest integer, so the greatest integer of -3, that is an integer, so you get -3. It doesn't change it. If I ask for the greatest integer of 1.99, what would that give me? 1. If I ask for the greatest integer of -4.2, be careful here. If you think about it on a number line, here's -4. Yeah, -4.2 falls between -4 and -5. The smaller one is -5. So you can't get out anything bigger than what you put in. Do you guys understand what this greatest integer function is doing? If I wanted to draw the graph of it. So if I asked you to graph the greatest integer function, we've always drawn our graphs the first time by making a t-chart, so that's what we'll do. If I put in 0, what is the greatest integer of 0? 0. Now, if I only put in the integer 0, 1, 2, 3, that's not going to help me here because I just get those numbers out. So with the greatest integer function, you have to put in some decimals. If I put in 0.5, still 0. What if I put in 0.9? What if I put in 1? 5, 0, 0. 0.5 is still giving me 0. 0.9 is still giving me 0. But when I put in 1, I get out 1. So anything between 0 and 1, when I plug that in, I'm getting out 0. Now, it's getting closer and closer to the 1 on my x-axis, right? And I could have put in like 0.99, 0.999. So kind of like on our piecewise functions where we always had to plug in the endpoint even if it wasn't equal to. We're going to have to go all the way up to this point, and I'm going to end it with an open circle. I'm going to be down here right up until that point when I put in 1. That's when this piece ends. But then when I put in 1, I get out 1. What if I put in 1.5? What do we get? What if I put in 1.9? What if I put in 2? Okay, so I'm going to stay on this step up until I put in 2. So the moment I put in 2, this one ends, and it jumps up to the next one. Okay, and you would stay here until you got to 3, and the pattern just continues, right? It goes in the negative direction as well. If I put in -1, -1 is an integer, so I get -1. If I put in -2, I'm getting out -2. So that's why this is called the step function. It just looks like stair steps. And these just keep going. The same pattern follows. So when I'm looking at these, I have a closed circle on the left, open circle on the right. It's just a horizontal line and then it jumps up one. You guys understand how I got that graph? So we're just going to practice graphing a few variations. If I asked you to graph the greatest integer of x plus 3, basically what we have to do on these is get one full step, and then once we know the pattern, we just continue our steps. Okay, so we're just going to work on getting that first one. So if I put in 0, the greatest integer of 0 is 0. 0 plus 3. If I put in 0.5, the greatest integer of 0.5, 0 plus 3, still 3. Okay, if I put in 0.9, the greatest integer of 0.9, plus 3. So I'm staying on this step. But what happens when I put in 1? Greatest integer of 1 is 1 plus 3. So when I put in 1, it jumps up to 4. So that means we put an open circle below it. And now we know what these steps look like. Closed circle on the left, open circle on the right, jumps up 1. So I can continue this. My rule, I'm going to ask that you do a minimum of 3 steps on any graph that you draw. And then, just to show that the pattern continues, you can just put like ... on both ends to show this is going to keep going. So I want to see at least 3 steps on your graphs. And then you can just put the dots to show me it'll keep going. What if I did this? If I asked for the greatest integer of x minus 2. So if I put in a 0, 0 minus 2 is -2. What's the greatest integer of -2? So 0, -2. I got out an integer, so that's the beginning of a step. If I put in 0.5, what's 0.5 minus 2? -1.5. The greatest integer of that? Still -2. If I put in 0.9, 0.9 minus 2 is -1.1. What's the greatest integer of that? But what happens if I put in 1? 1 minus 2 is -1. Greatest integer of -1? So you put an open circle under it to finish this step, and now we know the pattern. So you just need at least 3. More is better, but that's our minimum, and you can go either direction with it. The steps will all look the same with their open and closed circles. So they'll all have the same length, all have the open circle on one side, the closed on the other. Are these okay? Let's look at this one. Greatest integer of 1/3 x. So we really just need our t-chart to figure out what one step looks like. if I put in a 0, 1/3 times 0 is 0, greatest integer of 0. Okay. We've been putting in like 0.5. If you do 0.5 times 1/3, what's that give you? Okay, so 0.166, so what's the greatest integer of that? 0. Okay, if you put in 0.9, 0.9 times 1/3, 0.3, so the greatest integer of 0.3, still 0. Okay, if I put in 1, 1 times 1/3, 0.3 repeating, greatest integer of that, still 0. Okay, my step hasn't ended yet. What would happen if I put in a 2? 2 times 1/3. 0.6, so the greatest integer of that is still 0. When will this step end? Never? What happens when I put in 3? 3 times 1/3 is 1, the greatest integer of 1 is 1. So that 1/3 just stretched my step out. So now we know this step is 3 units long. So I'm going to be on the next one until I get to what number? 6. Okay, you need at least 3, so you're welcome to go either direction. So that 1/3 made my steps get really long. What do you think it would happen if I multiplied it, if it was a 3x in there? It would be a really short step. It would jump up when you plugged in a 1/3. So multiplying them will either make the step longer or shorter than we're typically seeing. All right. Do we need more practice with graphing? I want to look at one scenario here. An express mail company charges $20 for a package weighing up to 2 pounds and $2 for each additional pound or fraction of a pound. That's kind of how postage works, doesn't it? If you mail a letter, as long as it's under a certain weight, you have to put one stamp on it. What happens if it's over the certain weight? You have to put another stamp on it, okay? So that's kind of how postage works. Let y equals c of x represent the cost to send a package weighing x pounds. Graph this over the interval 0 to 6. So I am not writing an equation here, I'm just drawing a graph. From 0 to 6. Is my pounds, y is my cost in dollars. What is the absolute least amount I would pay for mailing my package? They charge $20 for anything up to 2 pounds. So 20 is the cheapest this would be. Notice my interval starts with a parenthesis. So what kind of circle would I start with? Open circle. All right, is everyone with me on this? Peyton, pick your head up. All right, so we're starting at an open circle. The absolute least it can charge is $20. If I walk in there with even just a small envelope, it's going to cost me $20. So I'm going to start my open circle up here. How long do you pay $20? For anything up to 2 pounds. So if it's exactly 2 pounds, you're still just paying $20. So this whole step, anything between 0 and 2 pounds, I pay $20 to mail that package. But what happens as soon as it goes over 2 pounds? I pay $2 more. So it will go up to $22 as soon as I go over 2 pounds. What would I put up here, do you think? Open circle. And then I'm going to stay there, and that's for each additional pound. So if it weighs 3 pounds exactly, I'm still just paying $22. But as soon as I go over 3 pounds, what am I going to pay? 24. So it starts with an open circle, so it goes up another 2. And that's for up to 4 pounds. And what happens if I go over 4 pounds? $26 from everything from 4 to 5 pounds. And if I go over 5 pounds, I think we're at 26, so 28 for anything until we get to 6 pounds. Okay, ends with a closed circle, and I only asked you to graph it between 0 and 6, so that's my whole group. Do we need another problem like that? Okay. So, that is the end for today. I have a handout for you.